Introduce us to some new perspectives.
Yes. Yes.
Okay.
And just you can tell people that they can use my Twitter handle. Test.
I think we're ready to start again. So our next speaker is going to talk to us about another quality issue and new perspectives in coding. And we're free to use his Twitter handle @Girba. Here's Tudor Girba.
Hello, everyone. Let's try again. Hello, everyone. And one more time. Hello, everyone. Okay, this is good. It's a great pleasure to be here. It's actually the very first time I meet somebody that actually programs ABAP. Honestly, and it's really cool. So my name is Tudor Girba, and I work as a consultant and a coach. And when people ask me what I do, that's what I do. I help engineers solve problems without reading code. Does it make sense? So let's take a vote. Before we take a vote, I want to get to know you a little bit. So how many of you would say you're a developer? Okay, so a good majority. Like if you don't know if you're a developer, you spend 50% of your time in front of an IDE, you're not. So again, who's a developer? Okay, Excel doesn't open like. Okay. So great. Let's go back to this topic. So who thinks it's strange? I actually help engineers who thinks that's strange. Just a few. Okay, let's talk a little bit about that. In fact, let's talk 45 minutes about this. So would you agree if I say that developers who would agree with that? Like let's say 50% of the time plus minus whatever, something around that. No, keep your hands up. So a good majority. Yeah. Would that be fair to say? Okay. When was the last time you talked about? Not about coding. Not about the code you read, but about how you read code. You can't. So somebody here can't remember. Anybody? Last week you talked about how you read code. Great. One. Anybody else? Sorry. Yes. You spoke this way, and before that? A month before? Okay, so somebody else here said today. So do we have 3 persons that remember talking about it in the recent times? Anybody else? So the vast majority here do not remember ever talking about, or not in the recent memory, talking about how we read code. So does that not mean, in fact, I'm visiting conferences quite often. And it's never a subject that happens to be mentioned. It's not It's not. It's not a hype thing to talk about. Thing we never talk about. Spending 50% of the budget on something you never talk about can't particularly be a good thing. Would you agree with that? So I think that we at least owe it to ourselves to talk about it. Let's do talk about it. So let's take a little bit a step back. So if you think about, just think of the interface that you're exposed to when you're dealing with code. If you take away, the whatever you have, the navigation or bells and whistles here, there, what you're ending up with is a big text editor. The largest majority of your screen real estate is really taken up by a large text editor. So what do you do when you're faced with a text editor? You read, because that's the natural thing to do. Now let's read. So what I've done here, I took 250,000 lines of code file, and I'm simulating incredibly fast reading. Like none of you can actually read this fast. In fact, lines of code, if you read really fast and it's constant, that means, let's say, 1 line in 2 seconds, it would take you about a person month of work to read. If you don't believe me, look here. I'm paging down right now. This tool does not scale. Code reading does not scale. But then there is another problem with it, and I call it the magnifier glass problem. Imagine you would hire somebody to build you a city. And then you said, I give you a tool. It's the perfect tool. It's the magnifier glass. Would that make sense? No. Then why would we consciously spend most of our effort in front of this interface? Does it make sense? I think it doesn't. Now here's the other interesting thing. You're all here. How many of you are here in business intelligence, SAP, event and all? Like business intelligence? 1, 2, 3. Okay. Databases? Okay. Great. So a good majority of you. Now, just think about what's the first thing. If I give you 1,000,000 rows in a database, which is not even that much, but if I give you 1,000,000 rows in a database, what's the first thing you? What do you filter? You filter somebody. How do you filter the relevant data? You created. You create the index? No, seriously, let's have a conversation. So you create an index. Grouping. So what? Yes, exactly. So you want to say, you do a select statement? You do a select statement. It's a natural thing to do. And then what you do? Then you look at the result. Maybe you're going to refine your query, right? You look at the result again. Maybe you write another query. You triangulate. Maybe you do union or whatever. You group it, and then you look at the data and say, oh, now I know. And then you move on. Would you agree? Would that be a natural thing to do? Yeah, this is how you go and figure data out, right? Now I give you 1,000,000 lines of code. What do you do? Is there a qualitative, is there a difference? Actually not, right? So we like To be honest about what? How to read the code, right. Before you read the code, you go and understand the domain. Just like you do with the data, by the way, right? Before you actually go and do the data, you go and understand the domain. Still, but when you actually approach data, you don't manually go and scroll through it. You build a tool, right? But when we look at code, we all of a sudden wave away everything we know about data, and we choose to treat it as text with occasional hyperlinks. Or with an outline, lovely, right? But without the page numbers. So why is there so? Is there no another way to look at this thing and not see text, but see data? And what would that happen? What would that make of the experience of actually going and approaching the system? So, problem here is that when we think about software development, we think about the active part. Yet we spend a significant of our effort not doing the active part. Right? We talk about HANA, and there are lots of acronyms in the SAP world, which, forgive me if I'm not able to spell them out. But they're all about how do you build things. Occasionally, somewhere, somebody talks about, yeah, there will be a migration, but it will be guaranteed to be smooth. Right? That's how we think about software development. And I think this is fundamentally wrong, because we are not addressing the full problem. Now, do we actually want to read code? Usually, no. Most of the time, people want to just understand enough in order to make a decision. Read the code. Like some people here do want to read code. Right. When you buy a car, you want to look into the engines and look at how it looks like. Do you want to do it every day? You want to see the structure? Why you want? That's agree, but that's what I'm saying. You don't want to read because you can't read. I just saw a system. You want to see the code, but you don't want to read the code. That's where the difference is. There's a difference between I want to understand whatever I'm interested in. I want to understand its structure. I want to see if it's, all the quality rules that I want to put in place are in place indeed. But I don't necessarily want to read, because reading is the tool that we use in order to actually make the decision. So somebody... This was the bytecode of my speech. So, the way you fix this problem, do you notice something here? This upper part here has a name. It's the development part. It's the thing we talk about. But the lower part doesn't have a name. And that's why we end up talking about code reading. But code reading is the tool, it's not the activity. Sometimes we talk about analysis, but analysis is usually associated with tools. It's not about with my mental process. So I think that as an industry, we lack a term here. We don't, there's a big difference when you talk, anybody here is doing some sort of automatic testing? Automatic testing. So sometimes you're doing some automatic testing. So half of the people around. Now, 15 years ago, automatic testing was not a subject. Like there were people doing it, but it wasn't really a subject of conversation. What happened is that we gave it a name, and we started to talk about it as an industry. And now we don't talk about should we do automatic testing, but how. And it's not that we have just one technology, but we have many technologies to choose from, and opportunities and different kinds of approaches. That's the difference between having something clearly named and something not clearly named. So I gave this a name, and I called this assessment, and I built a whole method around it. It's just called humane assessment. You can find more information here on this website. I won't go much into the details, but just show you that what's the essence of it. And the essence of it goes like this, and it's about how do we approach decision making. And one model in which we can think about, yeah, this is let's say an ideal model of decision making would kind of go like this. I start with a hypothesis. Here, I have an idea. I think it should be like this. All these classes that are here should be calling only this part of the database, but not the other one. Then I will apply an analysis, and I'll get the results. I'll interpret the results, and then I say, am I confident? Is it true? Are all of them just working there, or are they also using the other part? Because if they are all isolated here, it means that I can maybe carve this part out and isolate it nicely. But if it's using everything from everywhere from the database, then all of a sudden I'm in a different situation. So if I have that analysis, then I can go and act. And it's very important. This acting part is really, really important. Because there's very often that you're presented with information, and there's no change. The previous talk, for example, talked about how simply showing some sort of results does not lead to a change in behavior. There's no action. So that's not enough just to say, oh, I have 10,000 warnings. It's just, if there's nothing to change, it's not enough. It's for nothing. In fact, for me, this is the only measure of usefulness for a tool. Does it affect the way you make decisions? Does it affect your actions? If it doesn't, you can throw it away. It doesn't matter how much it costs. And this applies to absolutely anything, I think. But the problem here is this. Software systems are incredibly contextual. And because software systems are incredibly contextual, there is nobody in the world that can predict what your problem specifically. Nobody can predict that. Have you seen there was, at the beginning, there was a presentation about the new feature of HANA of supporting text search and sentiment analysis. Have you seen that one? Did you notice there was a really interesting example there with the Bavarian flavor of a certain type of sayings, right? Did you see that one, right? That one is incredibly hard to, you don't know, if you're an English speaker, it's really hard to predict that kind of that type of situation. But now imagine, do you remember there was also something about sports? Now, could you imagine a combination between the two? A Bavarian dialogue talking about a Bavarian specific sport. Now, this basically explodes the possibilities. And there is nobody in the world that can predict everything that you will possibly need. It is for this reason that no tool in software systems is even more difficult, because you have usually you're into the millions of variables. And nobody can predict what you need. You're the only ones that can. You, when you're inside your system, you can. In the same way you choose your technology, in the same way you should be able to choose your tools and craft those tools for your problem. So that's why this here is not guaranteed. In most cases, you don't have a ready-made tool for your particular problem. There is no tool that answers your specific question. That's why you're going to code reading. Because code reading is the most malleable tool we have at hand. It can deal with absolutely any context. The problem with it is manual. The other problem is error-prone. So you have to ask yourself, do I have a tool? And if you don't, you should be able to build one. In the same way, you're building a tool for somebody else to automate somebody else's decision making. You know, in a business intelligence, the situation is like this. The CEO or the board of directors, they want to have a certain question answered. Right? They have that specific point of view. They really want the data. They want the answer to this question. So what happens is at that moment, they give the problem to the business intelligence unit. The business intelligence unit goes to the data, digs the information out, transforms it, presents it, and then gives it back to the ones that can make the decision. Now, this implies that basically, as a company, you're taking away part of your effort, investing it into a tool, and sometimes you might be using that tool for a very limited amount of time and then throw it away. And still, this is a profitable proposition. Now, who's doing the tool? You. And when you have a problem, you owe it to yourself to not default to the most manual way of approaching that problem. Because the same economics should be at play in that situation too. Now, what this implies is that the cost of creating this one should be almost zero. Imagine you could create any tool you want within, let's say, 15 minutes. Any tool, extract any information you want, build any view you would like about your system. Would that not change dramatically the way you experience your system? Now, to show how that happens, that's what we're building this open source project, which is called Moose Technology, the Moose platform. That's a platform. It's for us. It's not a tool, in that it's dedicated to developers, and we treat developers not as clickers but as developers, which means that we see developers as a special kind of users that know how to program. So we give you the tools to program your tools. And I'll just want to show you a couple of things. So here's, for example, a very simple kind of an interface. Here I'm selecting, in this case, I have here a Java system. I'm selecting all the classes here. I'm looking at some of those that have some annotations, and then I get the result here, 50 out of 2000. I can take a look at this one in a different way. Maybe I'm looking at it as through a graphical point of view, just to see the distribution, how the classes are distributed throughout the system. What you see here is a tree map of the package structure. I can click on anything, so all the pictures here are live. So if you can click on them, you can get results on the other pane. And you can basically scroll to the right here. You see a different view inside the class. In the same way, you can also take a look at systems in 3D if you want to. Again, this is a kind of a tree map, but here you have metrics also mapped on the vertical, and all of that is interactive. But for us, the most interesting thing isn't that, but it's this. So what you see here is a little visualization that groups just a couple of classes and the annotations that are used in common there. So the annotations and the classes are put together in the same picture, and then we cluster them just so that we see which classes share the same annotation, for example. Now, the interesting thing is that this is the code that produces that picture. Now, our job is to have no scroll bar over here. Okay, that's what we do. That's what this Moose is all about. How do we make the cost of writing and how do we cram as much expression as possible in a very short space, in a very small space, so that you can express all sorts of ideas and put a picture on top of them. So here's a different kind of an engine. It's not just about analysis, but this is a different engine, which is about how do you create parsers. So we have this is a parser, for example, for SQL, and you have even debugging tools that go with it. Here's a way to navigate through the models. We have different models to represent software systems or other kinds of systems. And you have here, this is a kind of a Java doc, but in an interactive way. So this now is a visualization of the model that we're using, of the schema, basically. And we're using the same tools there as well. But better than just showing you an abstract, let me quickly give you a demo. So what you're seeing right now here is I have here a little system. So again, in this case, it is a Java system. So I can click on these ones. These are the classes. I have 4,000 classes. I can click on any of those. And let's quickly find out now all those that maybe are from Argo UML as a namespace. So what I'm doing now, I'm writing a little query. And I'm executing that query. So what I just got a moment ago was a little debugger saying, well, you have an error in your query, and I can resume. So it didn't crash my program. I can resume. So I have 2,500 things in there, so I can move on. And that's now. I wrote a little query, and now I have another system. So another group of classes, 2,500 of them. If I select one of them, I can see here this is the source code, for example. So now all of a sudden I can also browse source code. I can see inside the class in a visual way, for example. So here what you see is different methods, how they call each other. So again, these are all live pictures. So if I click on that, that's a method. So I have here a pane about that method. So here's the source code of that pane. And now if I click on this, I get a little browser showing me the source code. But the way I navigate, I never start from the text editor. I start from a query. I start from a visualization. Because that's the first thing I do. I don't edit. By the way, do you notice the irony that you're doing the reading in an editor? So now let's take a real problem here. So let's say we want to find out if all the classes that are deprecated in Java, you can annotate the classes deprecated. If I can safely remove them. Right? So I just want to clean up things. I annotated a bunch of things as deprecated. Now the question is, can I remove them? So the way I would do it is I can say, I want to select all the classes that are annotated with deprecated. So now I'm executing that. I get 28 of them. So just to give you an idea, that's the annotation, right? So how would I know now if it's safe to remove these ones? What about the find uses? What's with the coupling and dependencies? Rename and compile and see if there are compilation. Oh, you mean just change the name, right? And then you see if there are compilation errors. But I have 28 of them, and maybe I have 200 tomorrow. Will I go and change them manually? Okay, any other option? What does the compiler do when it shows you those errors? It's reading super fast for me. Exactly, that is true. But what does it exactly do when it shows you the error? So suppose, right, you go and rename that one, and then it shows you what? That it was used somewhere. Now let's think about it. What if the users are actually from within these classes? It would still not solve my problem because I would still need to go through all the errors for every one of these classes and check, are you not by any chance also deprecated? Because if you are deprecated, then it would be fine to remove you, right? So what else could I solve? How else could I solve this problem? Sorry? Build the dependency graph and then look for what? If the graph with deprecated nodes is isolated, that would be a possibility. But you know to write the queries, right? Let's write a query. What would the query be? Recursive? Do you actually need recursion in this case? Because if you find one, what's once? So what should I look for? So I need to look for, so I have here all the deprecated classes, right? then I should look. Let's quickly find out what can I find out from one of these class. So look, this class can tell me about client types. Now these are the types that are using this class. Okay? So let's see. If I have here a class and I say self client types, I should get the same thing as I click there, right? But now I am executing a query. So now I say any satisfy. The class is annotated with deprecated not. And then it says true. There is at least one that satisfies that situation in this case. So let's then find out from here. I will apply the same. What I will do is I will just copy the query that I just done for one of the 28 classes, and I will apply now for all of the other ones. So I'll say here, so I want to select from all those 28 classes, all those that have at least one client type that satisfies the condition that it's not deprecated. So now if I'm executing this one, I get 13 classes back, and these are the classes that I should look at, and not the other one of 28. Who understood what I just did? The theory, not the details. Who understood the concepts? You see, syntax you can learn. I mean, every time one of these abbreviations come with something, you have no problem going and finding out how you deal with the syntax once you understand the concept. So there's no problem. It took me 2 minutes to explain it to you, and there's no problem in understanding how that would apply to your situation. Now, I've just solved the problem in 2 minutes that might have taken you either not knowing or a significantly longer period of time to answer. Now, this is a small problem, but the same kind of tools you can apply to all sorts of other kinds of situations. So here's one situation. In this case, I went into this company, and this company said, well, look, here's our architecture. This one is built into a mature industry standard enterprise solution that has even shades, which is important, apparently, for architects. And it's a serious architecture. And so the cool thing about it is that it has two parts, the blue part and the red part. Now, this company says, and we're talking about hundreds of people behind each of these parts. Now, this company said, well, what we will do is we will renew this thing, and this is the old part, and we will take this one down, and we'll replace it with a completely new one that we will outsource to a completely new partner that we will work with, and everything will be great. Excellent. So this problem is solved. Now, there remains only one thing, because you see there are kind of number of connections that go from the blue part to the red part. The question is, what's going to be the impact on the blue part once we will remove the red part? That's the thing. Now, the problem is, where do you think the problem is? To find out where you can replace. Yeah. Anything else? Anybody else sees another problem? To find the interfaces, yeah, but they're here. Look, there's the edge here. Goes from there all the way to here. This is a serious architecture built in an serious enterprise solution. You don't know if this is true. Exactly. You don't know if this is true or not. So the first thing you want to know is this true or not? That's the first problem you have. Before you're even beginning to think about how you're going to solve the real problems, you first have to be able to say if what you know is true or not. This comes before anything else. And this is a basic problem. And we are not allowed, and we shouldn't call ourselves engineers if we are not able to distinguish real from unreal. We should be equipped with these things by default. Now, so the way we've done it is, I was okay. Then I went in, and it doesn't really matter. You know, it took me quite a bit of time. I shaded everything except for the blue and the red part, because in the end, this is what they cared about. And then I said, well, look, they said they just wanted me to give them the to tell them the list of the dependencies, just so that they can update their diagrams, and that would have been, you know, perfect. But I said, look, if now that I have the dependencies, I can build you this picture, right? Now, building the dependencies actually wasn't a straightforward thing, because they were using a very custom-made, homegrown, for 10 years technology, their own framework. Nobody in the world can know what it is, right? And nobody in the world can distinguish between which of the lines are good and which of the lines are bad. You have to program that specifically for that particular technology. Now, so it took the most of the time, actually, it took to find out and understand their framework and understand how to distinguish between good and bad dependencies. And then once we could do it, then we can say, well, I could draw this for you. But the interesting thing is that the code that it took to produce that picture is this one here. Now, this was a half-an-hour exercise. Do you notice the missing scrolling bar? This is real. This is not an exercise. Now, but there was another thing. They said, well, look, if this is the whole system, they said, we know that in the red part, if this is the system from one of the modules from the blue part, they said, we have in the red zone, right, we have one problematic entity. And then I said, well, let me quickly find out where are this problematic entity being used. And they said, well, it's being used here, here, here. You can find out where that one is being used, just to have an idea of the implication. How complicated is it to build, or to, how big is the problem? But then I looked into the package structure here. And then I noticed, oh, look, but this one resides in this subpart. So what happens if I look at all those things? Then I said, well, a couple of more appeared. So let me go and look at everything in the old model. And then this appeared. Now, what this means here is that if you don't have the data, you don't understand the size of the problem. And this can go in both directions. You will sometimes, say, oh, this is too complex. I can't do it. It's just undoable. And then in reality, the problem is small. Or the other way around. It says, oh yeah, it's just this problem. Well, in reality, the problem is much larger. But you know that because you're working with data all the time. I don't have to convince you of that. We should just apply the same skills to our own problems. Now let's take a look at another thing, because sometimes the real problems, really come from communications. Because here, this was a very technical problem. But sometimes problems come from communication. So in this case, we had this company that had two parts, the development part and the consultants part. And if you are working in a company like that have two parts, people that build and people that maybe go and install, and sometimes there's like tension. It's like they don't quite understand what you're doing, and so it's like, yeah. So people look, and then maybe they look into their whatever planning tool you have, and then they say, look, but you're only working on these 5 issues. And then we said, well, let's build a map. So what you're looking at here is that this is a nesting map of all the files with folder structures and color-coded by the different components so that they can understand which one was actually changed between one version and another. Okay? A simple thing. It's not a complicated tool to build. But then we put this one in the middle of the room, and then a conversation started. Again, it's just because you look at something and you see they are using it for all sorts of situations that you otherwise wouldn't think of. Now, this is actually, this is static analysis, like we also saw before. But sometimes you have other kinds of problems. So in this case, there was this company and says, well, look, every one of these bubbles here is a little system in our big ecosystem. And each one, they said, well, this is a Java system, but we have a little problem. Our problem is that we cannot create a new bubble fast enough. And we cannot keep up with the competition. Apparently, this was a big problem for them. And so then we said, okay, so this whole system is Java. They said, yes, everything is Java. Okay, great. So how are these things communicating then with each other? How do they put together? Oh, there is just this configuration system. And how is that one done in Java? Oh, no, that's just some XML files. How many? I don't know, not many. And we looked at them as there were like 1,500 XML files. Because each of these ones, there were like 200 components. Each of these would define multiple of those. And next to the XML files, there was also another scripting language, okay, which was defining actions that were triggered by the events that were described in the XML files. And then what those will map somehow at some point on the Java classes. Then what we've done is said, well, let's take a look and see what the dependencies are in these configuration things, right? And then we built this graph. Now, again, the thing here is that this was a central system in this company. It was not a side project. And nobody in this company for more than a decade knew the source of the problem. There's a difference between having the ability to extract whatever information you want from your system and not having it. Now, this is not a Java analysis. It is static analysis, but it's about XML. But it's not about XML in general, it's this specific thing. In fact, it took about 10 days to reverse engineer the schema because there were multiple schemas running at the same time in the same XML, describing the same data in 3 or 4 ways. And nobody actually would know what's the good way of defining it, this way or that way. Is there a conflict? Is there not a conflict? Complicated things. And then after that initial effort, you put a little bit of time, maybe half a day or so, and build an interactive tool because that's cheap. And then you have a tool with which you can start, you're in a position to start steering. This will not solve you, it will not help you identify the problem or the solution. This is the beginning, because now you know the problem. Now, let's take a look at another one. Sometimes, how many of you are looking at log files? You know, that's what I think it's worse than code reading is log reading. But you know why? No, you know why? Wait, I didn't say log understanding, I said log reading. You know why? You know why? Because at least you wrote the code, but the machine wrote the log. It's a terrible thing, I think. So, in this case, we had this problem, and there was this system that was like, the people were saying, yeah, it's you know, when we click on this, and then, you know, sometimes this one takes 1 minute, and sometimes it takes 5 seconds. I was like, whoa, okay, that sounds like a problem. So what would you think about if I'd say it like that? So if a problem sometimes, if I click on something and sometimes 5 minutes and sometimes it's 1 minute, so 1 minute or 5 seconds. Use a profiler, but what kind of problem would you think about? Caching problem. You see how immediate it is to go from something and creating hypotheses. It's a caching problem. Yes, you do need to create a profiler. The problem here is that this was a system that we couldn't stop. And there was no profiler put in place. But then we looked at the log file, and then we were happy because we noticed these parts in the log file. Cache hit, cache miss. We said, oh, wow, cool, excellent. But then we noticed, oh, look, there are 2 kinds of things. There's the query, and there's another query. 2 different zones in the cache, apparently. Nevertheless, so what we've done is now we took this cache thing and we built it. I parsed the log. We could parse the log files, right? Parse the log files from production, extract the information that we needed, the cache hit, the cache miss, and then we could produce a hit rate, right? That could go like this. But then we noticed, well, look, so the problem is that sometimes, you know, it's 85 and sometimes it goes as low as 20 or something. So it's really bad for a cache. But then we notice, actually, you know, from the query and the another query, not both of them are important. And we just want to split them away. So we split data, then we plot it again, and we notice, well, this one is pretty bad, but it doesn't really matter because it doesn't really affect most users. It just affects some users, and it's not really about the use case that we have. This, on the other hand, is really terrible, because look, now it's almost 100, and now it's 10%. It's really terrible what's going on here. Now, what do? We go and solve the problem? Well, no. We can't get this system down and just try. We need to be for certain that the fix that we're going to deliver is going to fix the problem. So before we're going to start fixing or looking for the problem, we first have to build a simulation environment locally, and then figure out if this is representative. How do we do that? Well, we take the data that we already parse, right? And then we start feeding it with the same timestamps, and we simulate multiple workers at the same time, and we start feeding it to the system so that we can, and then how do we test that the system is actually representative for the production? We plot again the chart, and then we compare the charts. Are they really the same? Yes, they are the same, which is great. So then we have a local system on which we can start playing. Then we can start looking at the code. We look at the code and we find out, oh, look, every 3 minutes we're throwing the whole cache away because we missed the configuration setting. Okay, so we fix the configuration, we do the right thing. Then what do? We deploy? No, we go to our local environment. We do it again, and then, and what happens is, we get into this zone. And now we're happy, because now we can go and deploy, and we did, and everything went fine. Now the round trip here was half a day about. Going from not knowing anything to having a very good idea of where the problem is. It took a bit more time to package everything and solve the whole thing. But the really cool part, the really essential part, was the ability to have a tool that interactively allowed us to play with that data and take it apart. This was a custom-made tool, specifically for this problem. We threw it away afterwards, but it paid off. Now, one other problem. So here is another problem, and there, again, it's a performance problem in this case. Now, this system here was built by, it had 4 different technologies working together. There was no profiler in the world to deal with this, because one of the technologies was a scripting language that it was proprietary. It took a long time to even, this is a whole other story, that nobody actually knew the syntax of it and the semantics, because there was only one interpreter, and you could give, I built a parser for it the very first time with the grammar from scratch. Again, it doesn't really matter. But the point here is, we started to have performance problems. And we started to have performance problems, and the way we started to fix the performance problems wasn't actually to fix the performance problems, but first we built a tool with which we could start profiling. But there was, as I said, there was no profiler in the world that could do those kinds of profiling very easily. So what we've done was, we've done a really stupid thing, which is, but good enough, which is we took all the log sources and we pushed them all into one stream. And then we could build a tool on top of it, a small profiler tool, custom made, just to show different kinds of views on those log files. And then we have things that would show us these kinds of things, the trees of executions. We could even take the entries and the SQL queries that were done inside, and then split them by table, so that you can find out which table actually consumes most of your time. Right, things like that. And this one we grew during the course of the project, and it paid off. And then we grew it, and we grew it, and at some point this was the natural situation. So what you see here, this is Eclipse on the one side, and this is this tool on the left-hand side, and 2 happy programmers working. This thing is absolutely possible. This is not science fiction. This is reality. In fact, if you think about it, Excel is doing that for business people. Why are we not having an Excel in our IDE? And it really starts with our, with the data problem. It is up to us to demand that, because the skills really are in this room. We can't just rely on those tools that come from some god from somewhere. Because nobody can predict your specific problem. People can predict classes of problems, but not your specific problem. Now, anybody knows what this picture is about? This is a picture from the 1930s about an analysis done for the London Underground usage. People went during the course of this project, they went over 4 million tickets. What you see here are really people going through those tickets. And the idea of it was to redesign the schedule of the London Underground. Now, do you notice how happy people are in this picture? No, they are not stupid. What they were doing at the time was state of the art. But now we know that they can do much better, because we are the ones that are building those tools for them. And we owe it to ourselves to look at this problem and know that we can do much better. Because where's the difference? Thank you very much.
We're a little bit over time, but maybe we have time for 1 or 2 questions. Does anyone have a question for Dr. Girba?
The tool you said, is it open source?
The tool is open source, yes. Okay. There are some parts that are commercial, specific language bindings and so, but the main tool is open source.
Okay.
And it's developed by a group of universities and supported by a handful of startups. It has about 200-300 man-years of effort invested in it.
Thank you.
Anyone else with a quick question? No? Okay. Thank you very much.
Thank you.
And we'll feel free to tweet to @Girba about the presentation. It's a big topic, and